Okay, lesson 9, writing algebraic expressions for my algebra kiddos. This is where you're trying to go from words to just a numerical expression, maybe with some variables. X is our most famous variable. He shows up quite a lot. And a variable just represents an unknown value, but thanks to rules, we know how to find it. Expressions will not have an equal sign. Expressions aren't necessarily set to equal anything, but an equation is. An equation will have an equal sign. These expressions we're talking about today won't. To write expressions with a variable, and you can follow along with me here, you should be opened up to lesson 9 in your workbook. To write expressions with a variable, let x represent the unknown amount. Use the following rules to translate words into a numeric expression. So for example, words that will help you know if you need to add more than, some, increased by, together, in all, those are where you would add. Words that would tell you where to subtract would be like less than, difference, reduced by, shortened, fewer than, those would be a minus. To multiply, you would see words like product or factor of, multiplied by, or times, and with division would be words to look out for division would be per, quotient, percent, out of, or ratio. So those are words that you will translate to a numeric expression, either add, subtract, multiply, or divide, along with a variable x. Continue reading here. It says when simplifying expressions combine like terms. Like terms have identical variables with identical exponents or are constants. Constants are numbers with no variables. The 3 here is a constant. There's no variable. 3x cannot be considered a constant because it has a variable, x. This would also be saying 3 times x. Whenever they're just together like that, that's the same as 3 times x. Like terms have to be identical. So we could combine 3x plus 2x because there are no exponents. They each have an x and one constant. If the 2x were squared, we wouldn't be able to combine because they don't have identical exponents. So we can combine those. 3 plus 2 is 5. So 3x plus 2x is 5x. Okay? That's combining like terms. Variables that are like terms may be combined following the order of operations. You still got to remember your PEMDAS. Alright, so go ahead and pause the video now. You're going to do the classwork on your own. And, okay, I'm sorry, rambling. Do the classwork on your own. Pause the video, do that on your own, and then replay the video, and we can go over the answers together. But you need to pause it first, do them on your own. Once you finish the classwork section examples, then replay your video, and we will go through the answers. But pause it. Now, if you haven't already, pause. Pause it. Okay, for that first one, 9 more than a number would be x equals 9, not 9 plus x. This is 9 more than a number. Our number is x. That's our variable. When you add 9 to it, that's 9 more than a number. The x plus 9, or the 9 plus x here is like saying a number increased by 9, or 9 plus a number, which wasn't what the first example was. So the first one should be x plus 9. Your second one should be x minus 6. The third one, a number increased by a factor of 12. 12x. Or if you put 12 times x, that's fine, but then the two x's get confusing. So if you can just squish them like that, that's okay. That will mean multiply. After that, a number increased by 3. Same as the first one there, a number